All right, y'all. So what we're going to look at today is something called orbital notation, and that is going to be sort of a visual way that we are going to represent electrons and atoms, and this is going to help us figure out where and how one atom bonds to another. So looking at, okay, we can see this visual representation of the electrons and oxygen. We can clearly tell where the two hydrogens are going to come in to make water, and why it happens like that. So this is definitely going to lead us into bonding and literally why every formula in the world is the way that it is. So here we go. So orbital notation. As we start this, it is important to keep some of our the information about quantum numbers in our mind because it's going to control how we do this. So just as a reminder, your principal quantum number is dealing with your distance from the nucleus, and we describe it with energy levels 1 through 7. Your orbital quantum number is describing the shape of the electron path, and we have 4 different ones. We have S, P, D, and F. And then our magnetic quantum number, that is describing the orientation of the path in 3D. And for each of our sublevels, we have a different number of orientations. For S, we had 1 orientation. For P, we had 3 orientations. For D, you have 5 orientations, and for F, we have 7 orientations. Okay, so hopefully that was all now fresh back in your head. One thing I want to point out about energy levels is that we can talk about them a little bit more specific. When electrons are all in their lowest energy level possible, so they fill the first, then they fill the second, then they fill the third, we call that the ground state. Okay, so electrons are exactly where they're supposed to be. That's the ground state. Sometimes electrons can have too much energy and they jump to a higher energy level, and that is called the excited state. We're going to look at the excited state a little bit more later, but I wanted to put it in here now while we are already talking about energy levels. So electrons where they're supposed to be, ground state. When they jump to a higher energy level, that is the excited state. Okay. Some other things to keep in mind is that one of the most important statements we said last time was that each orientation of an orbital holds a maximum of 2 electrons, and that is going to be true. An orientation can only hold 2. And then for each of our sublevels, there was a specific number of orientations. So go ahead and fill this in. All right, so for this, that means for S, there was 1 orientation, P, there was 3, D, there was 5, F, there was 7. So hopefully you filled that in as well, okay? So then, based on the fact that every orientation can hold 2 electrons, based on the fact that we have reviewed how many orientations are for each sublevel, go ahead and fill in now how many electrons are in each of those orientations. Okay, so 1 orientation for S, holding a maximum of 2 electrons in each of those orientations. So 2, 6 for P, 10 for D, and 14 for 7. So hopefully you got that. Okay. So the periodic table is pretty magical. It follows this idea of the orientations, how many electrons are in that sublevel, the energy levels 1 through 7. So let's take a look. So for example, 1, 2, 3, 4, 5, 6, 7. You see that going down on the left. Your energy level corresponds to your row. Takeaway number 1. Okay. Takeaway number 2. If you look at a periodic table, there are 2 columns in this purple section on the left. Like, look at the actual periodic table, either the little sticker you have, the one on the wall, whatever, okay? 2 columns on the left, that is the S sublevel. Hey, how many electrons can go in there? 2, not a coincidence. Over here, 1, 2, 3, 4, 5, 6 columns on that section on the right. 6, P, 6. In the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Also not a coincidence, okay? So these sections of the periodic table correspond to the different sublevels. That is takeaway number 2. Okay. After that, please also notice that there's a weird shift. Highlight this, circle it, color it, whatever it is that you need to do that is going to help you remember it. There is a very odd shift right here in the middle of the periodic table. Notice that even though this is row 4, this is 3D, this is row 5, this is 4D. Super annoying. All right, I am not going to get into why that is the case. It is beyond the scope of a high school chemistry class. It has to do with nuclear, pole. Let it go and just remember it. All right, so that is takeaway number 3, that 3D starts in row 4. 4D starts in row 5. Okay, so key takeaway, the 3Ds shift. So 4S is filled before 3D. 5S is filled before 4D. Super annoying. Again, just go with it. All right, trust me. So that was takeaway number 3. Takeaway number 4, all right, is that we are going to fill atoms, all right, in the order of the periodic table. So you literally start at the beginning and move through. So this is 1, you fill that. Then you get to the end of the row. It's literally like a typewriter. I've literally had students who in the past get to the end and I can like hear them go ding. And then you're back here and you go across. And then ding, back here and you go across. So it's 3S, then 3P, ding, then 4S, then that super annoying 3D, and then 4P. Okay, so takeaway number 4, fill the orbital notation, which I know you don't know what that is yet, but write it down anyway. Takeaway number 4, fill the orbital notation in the order of the periodic table. So 1S, then 2S, then 2P, then 3S, then 3P, then 4S, then that annoying 3D, then you're back to 4P. Ding, end of the row, 5S, annoying 4D, 5P, ding, end of the row, 6S. And that is your last takeaway. The last takeaway I need you to understand for today is that for this class, we will not be going past 6S. Okay, that is the last takeaway. We will not go past 6S. And again, some of this may not make sense yet because you're not doing it yet. That's okay. I just want you to understand that you can follow the periodic table and that each part of the periodic table corresponds to an energy level and corresponds to a sublevel. And then the number of like elements in that sublevel corresponds to the number of orientations. That's actually pretty crazy to think about. All this stuff about quantum numbers you've learned predicted the shape of the periodic table. That's pretty awesome. So as we do these things, we're going to have 3 rules that we need to follow. Okay, so make sure you're pausing and taking notes and getting these 3 rules down. Aufbau. The Aufbau principle states that electrons are going to fill the lowest energy level first. What that means is you're not going to start randomly at energy level 3. No, you start at 1 and then you fill it. Then you go to 2, fill it, 3, fill, 4, fill, and so forth. Okay, energy levels will start at the lowest energy level possible. Hund's rule. Okay, so we know that electrons are negatively charged. So do you think that 2 negative things want to be close together? Hopefully the answer to that was no. Okay, electrons want to be as far apart from each other as possible. And so Hund's rule states electrons will fill each orientation of a sublevel before pairing up. Okay, electrons will fill each orientation of a sublevel before they pair up. This one's going to be a big one for orbital notation. So give it a little like boop, 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 star. Don't forget me. Don't forget Hund's rule. Okay. And then we have the Pauli exclusion principle, which you heard a little bit about when you were studying the history of the atom, right? The Pauli exclusion principle states that we don't really know where electrons are. That was one part. The second part of the Pauli exclusion principle states that electrons must have opposite spins. Okay, so again, this is going to come into play as we do orbital notation. So quick recap. Aufbau, start at energy level number 1. Hund, fill each orientation before pairing up. Pauli, make sure those electrons in the same orientation have opposite spins. So let's go. Let's take a look at how we do this. Okay, so as you recall, for orbital notation, I said we are visually showing how electrons fill the atom. So there are going to be multiple parts to this. First, you're going to say something like 1. Like 1. That is representing your energy level. Then a letter. That is going to be your sublevel. And then, depending on how many orientations there are, you're going to have a line. Okay? And that is your orientations. So from here, right, our energy level, you could have 1 through 7 listed there. Your sublevel, that's where you're going to have S, P, D, or F. And then your orientations, your lines, literally, like we're showing lines for this, okay? You're either gonna have 1 line, 3 lines, 5 lines, or 10 lines. Sorry, nope, not 10. 7. Okay, so there we go. Then the last thing is it's a visual representation of the electrons. So we have to show electrons in these things. And what we use for those are arrows. Okay, so that is representing your electrons. Now, remember, we said that an orientation can hold a maximum of 2 electrons. And then Polly said they got to have opposite spins. So the second one would go down. Okay, so that is electron number 2, and this is electron number 1. So take a second, breathe that in. Okay, so again, we were showing the energy levels, 1, 2, 3, 4, 5, 6, 7, the sublevel, SP, D, or F, the number of orientations, 1, 3, 5, or 7, and then we use up and down arrows to represent our electrons. So let's say we were talking about the second energy level, the P sublevel, okay? The P sublevel, remember, it has 3 orientations. So when we do this, we're literally going to draw 1, 2, 3 lines, okay? Or if you were talking about 3D, 1, 2, 3, 4, 5. This is how we are drawing this thing. The other thing I really want to point out, right, is that we have said, based on Hund's rule, that electrons are going to fill each orientation before they pair up. So this is super important to understand for these friends. So for 2p, you would do the up, then the up, then the up, okay? Hund's rule. So if 2p only had 3 electrons, and again, this is going to make sense once you start doing it, I promise. I just want you to hear everything. If it only had 3 electrons, we would draw them like that. So here we go. What are you doing? How are you doing this? Quick reminders. So your steps. Step 1, find the element on the periodic table. Calcium, great. Find Ca. Number 2, decide what is the last energy level, right? What is the last row that it is in? And then what is the last sublevel? Is it an S, a P, or a D? Okay, so find the last energy level and find that last sublevel. Number 3, how many electrons are going to be in that last sublevel, right? Are you the first electron of 2p, or are you the 5th electron, or are you the 6th electron? How many electrons are in that sublevel? Okay, and you just count on the periodic table. 1, 2, 3, 4, 5, right? How many columns of that sublevel? Rule number 4. Start at 1s when you begin to start filling these things, and then fill till where you need to end. Rule number 5, keep the rules in mind, okay? Like Polly, make sure you got opposite spins. Hund, make sure that you fill each orientation before you pair them up. So you have an example here, right? It's important to see this thing. So notice we've got 1s, 2s, 3s, 2p, 3p. Okay, so, and then up, down, up, down, up, down, up, down, up, down, right? Up, down, up, down, up, up. The reason these two are not together is because of Hund's rule, all right? And the reason we have these ups and downs, those are the Pauli exclusion principle. So let us talk about how these things are going to fill. So let's say we were doing carbon. Carbon is element 6 on the periodic table. Find it, okay? It is in the second energy level. That is the P sublevel, all right? And then carbon is the second one there. So if I'm looking at carbon, I know that I'm gonna end at 2p with 2 electrons, okay? I found it on the periodic table. Second row, second energy level, P sublevel, because it's that section of the periodic table, and then the second element in that section, 2 electrons. So to fill this thing, we start at 1s, up, down, 1, 2, 3, 4, 5, 6, okay? The number of electrons equals the number of arrows, always, always. Let's look at another one, oxygen. Right, so here is oxygen on the periodic table. 1s, 2s, 2p, 1, 2, 3, 4. Okay, so it's ending at 2p with 4 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Again, that was 1s up, down, 2s up, down, 2p up, 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 and then down. Okay, that was the order that I did that, and that is because of Hund's rule. 1, 2, 3, and then the last one went there. Okay, and again, it followed that periodic table, right? This is the S section, P section, D section, 1s, 2s, 2p, 1, 2, 3, 4. Okay, so what I'd like for you to do now is give this a shot. Go ahead and do iron. All right, so iron is element Fe. It's right here. Okay, this is the D sublevel. This is 3D. So this is where it gets tricky. Remember, we want to follow the periodic table as we do this. So 1s, 2s, 2p, 3s, 3p, 4s, and then 3d, 1, 2, 3, 4, 5, 6. Again, always following, let's go back to it, this pattern, okay? This filling of the periodic table, that is what told me where I was ending, right? I was doing 1s, 2s, 2p, 3s, 3p, 4s, and then I was coming over here to 3d with 6 electrons for iron, right? Okay, so let's pop back to iron. So 1s, 2s, 2p, remember, do each orientation and then pair it up. 3s, 3p. Now, notice 3d is on this line, but we are not doing 3d. We are doing 4s first, because again, we follow that order of the periodic table. Okay, 4s happens before 3d. Okay, so after 4s, we said that it ended in 3d6. So 1, 2, 3, 4, 5, and 6. All right, do calcium. All right, so calcium, here it is, element 20. That is row 4, the S section with 2 electrons. So that's where I end. Up, 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 down, 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 up, down. You kind of got really quick at this. Sometimes students in their notes like to just do an arrow like that. That's fine. And then we said it ended in 4s2. Do silicon. All right, so silicon. On our periodic table, that is element Si. So here it is. That is the third row, so that's 3. This is the P section of the periodic table, 1, 2. It's the second one. So going back to our picture, silicon, 1s2, 2s with 2, 2p was full, 3s, 1, 2, and then again when we got to 3p, we said there was 2. So as a reminder, make sure you put them in in separate orientations. Last one for today, do bromine. So for bromine, this was a big one. All right, element 35. This is row 1, 2, 3, 4. So this is energy level 4. This is the P sublevel of our periodic table, and it's element 1, 2, 3, 4, 5 in that column. So I'm going to be ending at 4p5. So here we go. All right, so there is bromine for you. A lot of arrows, a lot of work. It was 1s, then 2s, 2p, 3s, 3p, 4s, 3d, 4p. Okay, when in doubt, always reference back to this periodic table as you are learning this stuff to help you, and hopefully you've got those takeaways taken there. All right, y'all, you've got it.